Hi, everybody. In this video, I just want to do some more examples with roots. There'll be a mix of roots here, but a lot of focus on third roots, fourth roots, and just, some roots that we haven't seen before yet. So let's get started. The first one we have here is the cubed root of 8 over 125. Now, when you have a fraction, one way you can do this is you can break that apart and consider the top and the bottom separately. So I can take the cubed root of both the numerator and the denominator here. So the cubed root of 8, let's fix this, is going to be 2. And the cubed root of 125, is going to be 5. Now remember, what you're doing here for cube roots is you're thinking about, for instance, well, what number, when I cube it, would give me 8? Or in the second case, what number, when I cube it, would give me 125? So 2 cubed would be 8, and 5 cubed would be 125. When you bring in variables, it is a little bit different. So the easy way, or the shortcut way that we can do this here, is to actually use division. So this is the same thing as having x to the 6 over 3 power. And again, this is one way to do this, is we can treat this radical basically as a kind of exponent that has a fraction in it. So we can use that dividing by 3 idea here. And the answer there would then be 2, so x squared. Now, why does this work? Well, remember, you're saying, well, what thing when I square it would give me x to the 6? And x squared, when I cube it does give me x to the 6, because the rule there is that you would multiply those exponents. So we're basically using the inverse idea there, because we'd be multiplying the exponents to check it. You would use division to get that exponent if you have a variable or something different like that. For the next one, if you have more than one piece, you're just going to take it one part at a time. So I'm looking at the cubed root of negative 27 and also the cubed root of x to the 15th. Now the cubed root of negative 27 would be negative 3 here, because again, negative 3 to the third power would be negative 27. It does check out. And then here, because we do have a variable with an exponent, you could use that division idea. So 15 divided by 3 is 5. It'll be the same idea in the next example. So just kind of taking your time and looking at it piece by piece. The cube root of negative 8 is negative 2. This becomes x to the 3 over 3, which is x to the first power. But again, you don't really need the first power, so we can just write this as negative 2x. Looking at a fourth root here, I have the fourth root of 81. So you're saying, well, what to the fourth power would give me 81? And what actually works there is 3. 3 times 3 is 9, times 3 again is 27, times 3 again is 81. So the answer there would be 3. And then for the last one, looking at a fifth root here of negative 243. So again, just kind of asking yourself that same question. Well, what to the fifth power would be negative 243? And the answer there is actually negative 3. You do negative 3 to the fifth power, you do get negative 243. Okay. Now, I want to remind you that when you're working with odd roots, you absolutely can have negatives under the root there. They do work out perfectly fine. When you have even roots, though, you can't have a negative inside the root. That is not a real number. So for instance, if I did the fourth root of negative 81 instead, this would actually be sort of like a no solution, or, it's not a real number. Right? There's no way to get a negative when I do it 4 times. If I try, negative 3 to the fourth power, I end up with positive 81. Because there's 4 of them, I can never get that negative to stay. So anything with an even root, like a square root or a fourth root or a sixth root, you cannot have negatives in the root. You can have them on the outside though. So, negative 4th root of 81. Well, the 4th root of 81 we saw is 3, and then that negative would tag on. So that's perfectly fine there. But for under the radicals, just keep in mind as well, odd roots are fine because you can find an answer that works. But when you have even roots, they can never have a negative under the radical. You get a number that is not real. Let's do a couple more examples. Oh, and here's the one I just did. I guess I squeezed it in over here. So because you have that negative under the 4th root here, again, we can say that this is not a real number. So there would really be no answer for this one. With square roots, we do have imaginary numbers we use, but we don't really deal with that too much with 4th roots. Okay. And then one last one here, again, the cubed root of 64, and then also the cubed root of x to the 3rd. Cubed root of 64 would be 4 here. 4 times 4 times 4 is 64. And then you have x to the 3 over 3, which is x to the 1st power, or just x. All right, now one thing I do want to make note of and want you guys to recall is that if your n is an even positive integer, so like your radical is an even value, and you have the same exponent on the inside as you do the outside, then you actually have taken the absolute value of that answer, or of whatever number is inside. If n is odd, though, you can just write it as it is. So what ends up happening here is the root and the exponent cancel because they're the same. But when your power is even, we are taking the absolute value instead. Now, that wasn't an issue here in the one we just did, or in the last few examples, because most of our roots were odd. So we just wrote the answer as it was. But for instance, if I look at the first couple of examples here, you're going to notice that we have even powers, right? If there's no symbol there, there is a square there, it's a square root. So basically that root and the square cancel, but because they're even, the answer is actually the absolute value of -3 or +3. Now, why does this work out? Well, look at the original problem, right? If I simplify on the inside, -3 squared is +9. So when I take the root of 9, I am getting 3. So it does work out. It's just a little bit of a shortcut there. Here again, I have a square root of a square, so that's going to cancel. But technically, your answer would be the absolute value of x. The same thing will be true with this example I have here. You have even powers, so they are the same. They're going to cancel, but your answer is going to be the absolute value of x minus 2. Whereas here, because they're odd, they cancel, and my answer is just what's there as -5. So you just really want to be careful with those even powers. They're just a little bit more that you have to watch out for. One thing I will note as well is sometimes when you're doing questions, the question itself may say something like, assume x is positive, and in which case we do leave out the absolute value there because the answer will always be positive. But you really need to read the directions there. If it doesn't say that your x is positive, then you do need the absolute value symbol around those even powers. So if it does say something like, so let me say if it says, x is positive or x is positive values only or something like that, then you can leave off the absolute value symbol. So the big thing here is read the problem. So sometimes we do see that, and I don't want you to get confused and say, well, how come we do it sometimes and not the other times? If it doesn't clarify what values x can be, then you would need the absolute value symbol for any of those even powers here. But if it does clarify that x is positive, then we do leave it off in that case. So that does happen quite a bit. So it's something to just watch out for. In the next example, I have an odd power, so I don't have to worry about that here. My root and my power will cancel, and I'll be left with just 2x minus 7. Here again, I have an even power, so I have to be more careful. So I have the square root of 25 and the square root of x squared. Square root of 25 is 5. And again, here my square and my square root and my 2 for my power are going to cancel out. And then you are left with just the absolute value of x. So it does look a little bit funny for your answer here. But that would be the correct final answer, again, if you don't know anything about the x values. If it does say that x is positive, then you can just write 5x. But if it does not say that, then you do have to use the absolute value for those even powers. Now, the last one here I like because it's a little bit tricky. And if you look at it, it says the square root of x squared plus 2x plus 1. And you're probably thinking, well, there's nothing I can really do there. You actually cannot just split up addition and subtraction like we do with multiplication and division. So this is one group. But if you look closely, you actually can factor this. It actually factors into x plus 1 squared. So once I recognize that we can factor this, then I can see that my root and my power will cancel here. And again, just don't forget that you would have absolute value in that final answer because I don't know anything about the x here. So watch out for some of these as well. See if you can do anything further. This one happens to factor as a perfect square, so we luck out and we can simplify this example a little bit more.